Okay, the third line that pertains, the third special line that pertains to any triangle that we're going to look at is the altitude. The altitude of a triangle is the height of a triangle. The point where the three altitudes of a triangle meet is called the orthocenter. This point is not necessarily inside the triangle. So draw the altitude from point B. Sometimes it'll say the altitude of AC. This is going to go through point B, straight down through AC. It's a line, goes on forever. It's going to cross AC at 90 degrees. But we don't necessarily know that this is split in half. So we're not adding any marks, any communication that way. We draw the altitude to point P, and so this triangle has now been rotated a bit. We want QR, we want to imagine that that is flat ground. And P would drop straight down. Because this is outside the triangle, we need to extend QR so we can make sure that we cross that 90 when we're drawing it and go through vertex P. If we did that for all three of these points, we would have our orthocenter. So crosses PR at 90 and goes through Q. And if I think about continuing this, and drop it at 90 through R, you can see it's going to go into the next question, but they're all going to meet somewhere over here, my orthocenter. So let's look at determining the equation. Same as we always do. So for the triangle ABC, we've got vertex A, we've got vertex B, and we've got vertex C. Determine the equation of the altitude from point C. Let's plot those points. We have our 3 points plotted. Connect the dots, connect the triangle with our, you guessed it, straight edge drawing tool. Now, this line is going to go through C and cross AB at 90 degrees. My straight edge drawing tool has these other marks, so I can line them up and I can kind of see where it'll go. So we're going to want to do the math. The drawing is to supplement the math so we know what's going on. First step, if we're going to go through AB and it's going to cross at 90 degrees, we want to find the slope of AB. And when we have that slope, we're going to take the negative reciprocal slope. So we plug that into our handy dandy equation. Y2 minus Y1 over X2 minus X1. And the next step, you guessed it, we do the math. I don't know why I keep on changing colors here. 9 minus 1. 7 minus negative 5, 7 plus 5, 8 over 12, which we reduce to be 2/3. So the slope from A to B is 2/3. We could count that. 1, 2, 1, 2, 3, hey. 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 If we didn't do the math and we actually had a chart, we would show our rise and our run to get our slope, showing our work. Remember, we need the perpendicular slope. So we can say perpendicular slope or slope of perpendicular. 2/3, we flip that fraction, it's 3/2, and it's a negative. So right away, we know that the line is going to go from C and cross AB at negative. So that's our point. We really can take that slope from here, down 3, 1, 2, 3, over 2. And we can draw our lines, or connect the dots. And use that slope to draw those points. There's my straight line. There is the actual altitude from C, crosses at 90. I can see clearly a y-intercept, but again, this is just to support my math, so let's do the math. Step 2, found that. So the next step is we're going to use that perpendicular slope and a point, in this case, vertex C, to find our y-intercept. And we're doing it, even though we can see it, so that you remember what to do. So we plug in what we know. We have an x and a y from vertex C. We have a slope. We use our negative reciprocal slope because that's going to be our line. And now we math. -3 over 2 times 6 is the same as 6 divided by 2. Just make smaller numbers. 6 divided by 2 is 3. Times -3. To isolate the variable, add 9 to the right. Math is fair. Whatever you do to one side, do the other. So add 9 to the left. And we have our y-intercept. From that, we've got our final solution because we have a slope, we have a y-intercept, the height of the triangle ABC from vertex C, or the equation of the altitude from vertex C is y equals. And that's our line right there that we've drawn. Now the next thing, as we continue, is how do we find the length of that line? And if we knew the length of that line, could we potentially find the area of the triangle? Because area of a triangle is base times height divided by 2. You have the length of that line, we can find the length of that line. That's what we're going to do next. So flip the page, and let's do that example.